Today's lesson is about point-slope form. Your learning target says, I can write the equation of the line knowing 2 points only. So, what do you do when I give you only 2 points and I want the equation of a line and you do not know the slope yet? Well, that's what the lesson is going to help us learn. I want you to make sure you have the note sheet from class for the next part of the lesson. So here's a sample of a problem that I might give you. It says write the equation of the line that passes through the ordered pair 4, -4 and the ordered pair 8, -10. So if you look at your note sheet, there are 4 steps for this. I'm going to walk you through it, and you're going to make sure that you copy on your note page any calculations that I do. Now you're going to notice that I have 2 x values and I have 2 y values. And I have to subtract those amounts. And in reality, it doesn't matter where I start, but I generally start working left to right. So that means I'm going to take -4 minus -10, because remember, slope is the change in y on top. And then since I started with my first ordered pair, the one on the left, I would take 4 minus 8 as my denominator, because remember, the denominator is the change in x. And so when you do that, I'm going to do that down here, -4 minus -10 would give me an answer of 6 as my numerator. 4 minus 8 would give me a -4 in my denominator. So in simplest form, I'd have 3 over 2, and this negative sign right here, it can belong anywhere. It can be in the numerator, it can be to the side, it can be in the denominator. I just generally put it up on top. It doesn't matter where you put that. So the slope of my line is going to be -3 over 2. Pause me here if you need to catch up with your notes. Step number 2 says we're going to substitute either ordered pair into the formula as well as the slope we just figured out. So I generally, it doesn't matter which ordered pair you start with, but I generally go with the left side one, or the first ordered pair. The y coordinate is -4. The slope we just found out was -3 over 2. The x coordinate is 4, and we don't know b. All right, so step 2, all I'm doing is I am substituting an ordered pair in for my y value, x value, and then of course I knew my slope. Pause if you need to catch up with notes. All right, step 3 says we're going to solve for b. So on the last slide, I had this. This was my slope. This was my x value. All right. So if I were to simplify this and I were to take -3/2 times 4, I would get -6. So all I did was I multiplied my slope times my x to simplify this a bit. And then I have a one-step equation. I want b to be by itself. And so that simply means that I need to add 6 here so that that will disappear, and add 6 here. So it appears that 2 is on the left and b is on the right, and b is worth 2. Pause me if you need to catch up on your notes. Step 4 says to write your equation in slope-intercept form. Really, the only thing we need to know is the slope and the y-intercept. So y equals the slope, which was -3/2 times x, plus our y-intercept from the last slide was 2. we have the equation for the line. Okay, so it's time for you to try. I want to know the equation of the line that passes through 3, 3 and 6, 4. So step number 1, you're going to find the slope. So pause me while you do that and come back to check. All right, to find my slope, I took 3 minus 4 as my numerator, my change in y, and then I did 3 minus 6 as my denominator, or my change in x. And when I solve this, 3 minus 4 is negative 1. 3 minus 6 is negative 3. If I have a negative on top and bottom, they cancel. Two negatives, when I'm dividing, create a positive answer, so my slope is 1/3. All right, step 2. You are going to pick an ordered pair and substitute it into our slope-intercept form. So do your substitution and then come back when you're ready to check. Okay, here's mine. I used my y equals mx plus b. I used the ordered pair that's in the rectangle. I substituted 3 for y and 3 for x, and I used the slope we just found. And so now I can solve for b. That is step 3. So pause me while you solve for b and come back when you're ready for checking. All right, first I simplified. 1/3 times 3 gave me 1. So I have 3 equals 1 plus b. To solve that, I would subtract 1 from both sides, and it appears that 2 is what b is equal to again. All right, last step. You're going to take your famous formula. We found the slope. We found the y-intercept. Write the equation for this line. Pause, write it, come back when you're ready for checking. Okay, y equals the slope times x plus the y-intercept. That is the equation of the line that passes through those 2 points. All right, try this one all by yourself. I would like the equation of the line that passes through 2, 5 and 3, negative 4. So in your notebook, you're going to walk through the thought process, showing all 4 steps so that you could determine the equation of the line. So you're going to have to pause me here for quite a bit, do all of your work, and then come back for checking. All right, step 1, I'm going to figure out my slope. So I'm going to take 5 minus negative 4 as my numerator. That's my change in y. And 2 minus 3 is my change in x. So when I do 5 minus a negative 4, I get 9. 2 minus 3 is negative 1. I just prefer to have my negative on top, so my slope is negative 9/1. Step 2, I am going to substitute. Here's my formula. I'm going to use my first ordered pair, although it doesn't matter which one you use. My y-coordinate is 5. My slope we just figured out is negative 9. My x-coordinate is 2, and then we don't know b. So when I simplify this, I'm going to have 5 equals negative 18 plus b. Let me move that up a little bit. 5 equals negative 18 plus b. So I need to do step number 3, which is solve for b. I'm going to add 18 to both sides. That's going to give me 23 on this side and b on that side. I only need 2 pieces of information. I need the slope and I need the y-intercept. And then I can write the equation of the line. So y equals the slope times x plus the y-intercept. There is the equation of your line. All right, so here is the official point slope formula. If you look this up on Google, this is what's going to come up. It looks a bit different from slope-intercept form, but with algebra magic, we can rearrange it into a form that is familiar to us. Okay, so I have an equation in point slope form. It says y minus 4 equals 1/3 times the quantity x minus 2. So let's make a table of values that works with this equation. Now you know me. I am all for the easiest numbers in the world, but on this one, 0, 1, and 2 may not be the easiest numbers in the world. I need to look at what I've got going on here, and I might choose the number 2, because if I chose x is equal to 2, well then make it look good, 2 minus 2 is 0, 1/3 times 0 is 0. So all I have to figure out is what number minus 4 is 0, and that would be 4. So be careful when you're picking your numbers. If you pick the ever popular 0, 1, 2, you might end up with decimals or fractions. I would choose not to go down that route. So I'm going to pick numbers that I know are going to give me easy things, like my 2. 5 will also be an easy number. If I put a 5 in for x, 5 minus 2 is 3. 3 times 1/3 is 1. So all I need is a number minus 4 that equals 1, and the answer would be 5. All right, I have to pick one more easy number. I'm going to tell you a good easy number is going to be 8. I'm going to change my color here. So I'm going to put 8 in for x. X minus 2, or 8 minus 2 is 6. 6 times 1/3 is 2. So I'm just looking for a number minus 4 that will equal 2 in this case. So that number would be 6. So in this case, my easy numbers were not the go-to numbers. All right, would you go ahead and graph that? Put the graph in your notebook. I'll wait for you. All right, so when you graphed this, you should have had a nice linear graph that does not go through the origin, so it would not be a direct variation. I can get my equation right here, right off of my table. So remember, my slope is my change in y. It's going up by 1 over my change in x. It's going up by 3. So my equation starts y equals 1/3 x, and then we have to see if we have to alter things at all. So if I take 2 times 1/3, 2 times 1/3, whoop, that didn't come out very well. 2 times 1/3, I don't think I'm going to get 4. I think I have to adjust a bit. If I were to take 5 times 1/3, that's 1/3, I'm not going to get 5. I have to adjust a bit. And if I take 8 times 1/3, I don't get 6. I have to adjust a bit. And the bit that I have to adjust by is 3 1/3. So I feel this is the equation of the line. Would you look at your graph? Does it pass through the y-axis at 3 1/3? Does it go up 1 to the right 3, up 1 to the right 3? All right, well, let's go back to this guy. I told you earlier that we could do some algebra magic and make this work. So y minus 4 equals 1/3 x minus 2. All right, so we're going back a couple of units here. The first thing we want to do is distribute. So we're going to have y minus 4 equals 1/3 times x, and I'm going to make this an adding, a negative 2/3. All right, now I'm going to solve a one-step equation. Y is not by itself. To get it by itself, I'm going to add 4 to both sides. Y will equal 1/3 x plus 4 plus a negative 2/3, or negative 2/3 plus 4 will give me 3 1/3. Awesome. Interesting. Look, they are the same. So if I do a little algebra magic to my point-slope form, I can turn it into slope-intercept form. Okay, let's try one of those again, because it gets a little complicated, I understand. We're going to start with a table of values that works with this equation. Again, my famous 0, 1, 2 may not always work. In fact, I think 9, 10, and 11 might be good options. So if x is 9, I want you to calculate y. When x is 10, I want you to calculate y. And when x is 11, I want you to calculate y. So you're going to pause me now and do your calculations and come back for checking. All right, so here's what I calculated. Go ahead and pause me while you graph this. Let's see if you can find the slope-intercept form from your graph. So pause me now. All right, I'm going to do it from the table, and then we're going to check it with your graph. So I can figure out my slope, what I'm skip counting by on the y side, and that happens to be a 5. And then I can figure out what I'm skip counting by on the x side, and that's a 1. So it looks like my slope is 5. So I'm going to take that times the x value and possibly have to adjust. So if I take 9 times 5, I will not get negative 3. I'm going to have to adjust a bit. 10 times 5 will not give me 2. I have to adjust a bit. And 11 times 5 will not give me 7. I have to adjust a bit. And the adjustment actually is kind of a big bit, negative 48. So look at your graph. I'm hoping that you made it large enough that you can see your line will cross the y-axis at negative 48. And then you will count up 5 to the right 1, up 5 to the right 1. All right, so that is one way of converting point-slope form into slope-intercept form. The other way is to use algebra magic. So let me pick a good color. Let's try green. Oh, that's not a good color. Let me try again. I'll do it in black. So y plus 3 equals 5 times x minus 9. So back a couple of units, we learned that we have to distribute first. So my y plus 3 is unaffected, and then I'll have 5 times x and 5 times negative 9. Remember, I want y to be by itself. So in order to get y by itself, I have to subtract 3 from both sides. That leaves y by itself, and then we have 5 x's and a negative 48 on the other side. Well, it appears that I can get from point-slope form to slope-intercept form 2 different ways, and they are equivalent.